I think mainly it's the reliability side where the cool demos have to catch up, right? I mean, we see a lot of these demos, of robots doing impressive stuff, but to translate those YouTube videos into reliable shop floor deployments, I think that is where it takes time. So that's why I think it is some good way before the end-to-end AI really shows the promise, and a very good pragmatic midway is exactly what our approach is, what Mrutyunjaya highlighted as an orchestrated AI approach, where we still use the state-of-the-art AI models, but then give a solution that is reliable, robust, explainable, revenue generating today.
Hi, wherever you're joining me, I hope you're doing well, and a happy new year to you all. Welcome to India Tech Report, a podcast dedicated to chronicling and supporting the growth of India's deep tech and climate tech ecosystems. I'm Hari Arakli, and in this year's first episode, I'm joined by Mrutyunjaya N, Raviteja Chivukala, and Jagga Raju N to unpack why and how they started Perceptyne Robots and what it takes to build an AI-native robotic system out of India. Perceptyne is a Hyderabad-based company building dexterous dual-arm intelligent robots for industrial automation, currently focused on automotive and electronics manufacturing lines. The founders explained the gap they saw on real shop floors, where many assembly stations still rely on manual work, where traditional approaches cannot handle unstructured inputs, fine force control, or frequent product changes. The conversation goes into their vertically integrated hardware, including mobile configurations, and their PR5 physical intelligence software layer that orchestrates perception, control, and imitation learning-based skills like visual servo, slip-free grasping, and force-based assembly. You will also hear their take on the state of India's robotics ecosystem, the evolution of robots as a combined hardware and software challenge, and how they are moving from pilots with global automotive and electronics manufacturers toward larger deployments. Perceptyne, which turns 4 this year, is backed by 2 well-known deep tech VC firms, Yali Capital and India Partners. So, Mrutyunjaya, Ravi, Jagga, thank you so much for making time for this. Really looking forward to this conversation because I was telling Mrutyunjaya earlier, 2026 looks to be already shaping up as a year where there's so much exciting news in terms of developments on robotics and physical AI and all that. And so for me also, it's a happy coincidence that the three of you are at Perceptyne. You're building robotics products out of India, and you all are going to be the episode that I'm going to kick off my 2026 season. So welcome to India Tech Report. If you all can get us started a little bit in terms of your background to talk about how you guys came together and give me a sense of the conversations between the three of you that led to the starting of Perceptyne, and let's go from there.
Sure. Thanks, Hari, and wish you a very happy new year, first of all, and really honored to be a part of this. So just to give a brief background of who we are, probably the story of Perceptyne. I think broadly what we are building is dexterous, dual arm, intelligent, and general purpose robots for industrial automation. Now, if you double click that and go back to actually how industrial automation is today and what's the need for a product like what we're building. I mean, imagine you going to any shop floor of a manufacturing location, maybe in an automotive plant or an electronics plant or an assembly line of an electronics plant, maybe a phone assembly line or something. Contrary to popular perception that a lot of things, everything is automated in a manufacturing line, you would be surprised to know that there are so many things that are unautomated. Right, so many things that are done manually even today in a lot of manufacturing and assembly lines. In today's world, the number of products, the changes in products is happening much faster than it was a long time ago. For example, just to give you an example, if you take for example Tata Nexon, right? more than 100 variants of Nexon in the market today. Compared to 15 years ago, a Tata Manza would have had probably 4 variants when it was launched. Now, this is because consumer preferences are changing. Everyone wants a bit of a personalization in what they buy and so on. For whatever reasons, manufacturers are ending up giving a lot more variants. The SKUs that are being manufactured on a line or assembled on a line are changing much faster. Now, come back to the automation problem. If you build customized jigs, fixtures, a whole lot of customized automation solution, and the product itself undergoes a change in 6 months from now, or maybe 1 year from now, you'll have to repeat the whole effort. There is no question of ROI, right? So, net net, the summary is that what's happening here is a lot of stations are remaining unautomated because one, either you cannot technically solve the problems of force feedback, touch feedback, and working with unorganized solutions, or two, you build a highly customized solution which is not general purpose enough to adapt to future and does not give you the ROI. And this is precisely the problem that we have set out to solve. Can we build solutions, automation solutions that are intelligent, dexterous like humans are, and general purpose and flexible so that they can be adapted to different kinds of tasks and are affordable to customers? And that's when Ravi, my co-founders Ravi, Jagga, and me, we started Perceptyne in 2022 Q4, and yeah, the journey continues.
Can you talk a bit about how the three of you met?
Thanks, Hari. So me and Mrutyunjaya, we were colleagues at National Instruments. Me and Jagga, we were batchmates at IITM, and then also for a brief period roommates when we were working in Bangalore. So overall, I think the journey has been different for each of us, but broadly we've all worked in hardware, deep tech. Pretty much wanting to build in India. Since passing out of each of our respective colleges. I used to have discussions about like what needs to, and all of us, we used to bounce off ideas ranging from, laser weed removal, MJ, I think. Uh, yeah, so starting from that to coconut cutting, I think, MJ, I think, or something
Yeah,
like
yeah. I
that.
mean, we were thinking of how, I mean, back when even drones were very, very niche, you're thinking, how can we really incorporate tech into some of the pressing problems of, Indian design? Can we help in crop harvesting? Can we help in, some of the farming applications? A lot of ideas and discussions.
So one thing, right? Like anything that we build, like one of a few lenses that um, we would always put that by is one, it must be deep tech broadly with hardware because that's where our expertise and interest and passion lies. That was one. Two, it must be able to scale to very high scale, right? A lot of ideas are there, like pretty cool hacky ideas for small gadgets at home, etc. But then if you really put together what is the TAM that you would achieve and how big a business that it would become, a lot of them might not end up becoming such large businesses. So that was also one thing that, okay, like how do we build a strong high scale, high growth deep tech company out of India for the world. And that's something, that's a DNA that we all like very strongly share. Like and around that time, AI is AI still wasn't as as evidently powerful as it's today that day, but still we took a very sort of good bet there, saying that okay, AI will become very good in the digital world, and then in the physical world, uh, that's where the real potential of AI is going to lie. And for it to really manifest, robotics is the way, right? So that was like the thought process with which, like, okay, like, can we make intelligent robots? Can we actually make robots that you know don't need to be instructed like every atomic instruction by instruction, but rather do things as intelligently and dexterously as we humans do. So because if that can be done, that's the next unlock of automation. Like today, way too many number of applications and industries are still dependent on manual effort, and really that's where the next unlock is going to happen. This was a shared belief of all of us back in like 2022.
from my perspective, from my view, realize that it's matter of time that all the tech that was being developed in the AV space is going to kind of percolate into others, and robotics is one natural space where all that compute and computer vision side of things would percolate. So for me, the journey into robotics has primarily been through that route, Hari. While we all share a certain shared sense of how we see the tech evolving, kind of that evolved after our interactions with each other and while we are working. And today, I think we are one of the first robotics companies out of India, building everything end to end, right from our actuator designs to and the robots, and we just don't depend on off the shelf robotic arms to build robots.
Okay. Very briefly, I want to know if there's a story or an anecdote behind the name Perceptyne. What's the significance?
Yeah. So I think, I mean, every robot has three key aspects to it, or subsystems, if you may say. Like perception is one, and then you have intelligence that actually perceives and then sort of makes decisions, and then there is action, right? Intelligence is sort of like assumed to be there in robotics, so we wanted something that fuses perception and action. So, and dyne generally is the Latin word for action, dyne, dyna, etc. Like that's like force and action. So perceptine sounded like a good thing. That's, I think, nothing, no more magic sauce there than that. Yeah.
More importantly, we had a .com and the domain names all available for this name we invented. So it became a very easy decision. And .ai even so.
But yeah, somehow this name stuck. I think perception. I mean, it gives the feeler of perception, perceptive, etc. Having said that, I think in so many of the early days, I regretted, like, having needed to spell this place out, because when you're spelling this, our company name in mobile phone, every name there is a possibility of being mistaken. So I'm like, there were times where I was like, "Wait, why did we really name it like this?" But then yeah, I think the name stuck, and it actually, like, a lot of people like it. So yeah.
So let's talk about your products. That's the exciting part that we want to bring our listeners. You already built a couple of variants. I would imagine that you all take a platform approach and you want to iterate on those. So walk us through where you are at. What have you already built? What are they capable of?
See, broadly, we have complete 100% vertically integrated arms, with AI at the core of it. Right? In the other way of saying that, we've built truly AI native robotic arms. Right? Most robotic arms are just very dumb position repeaters, for the lack of better phrase for it. Right? So they just go from point A to point B to C, D to E, open the gripper, etc. Right? So even if there is intelligence, it's mostly achieved by strapping multiple systems from different vendors together, which more often than not doesn't really result in an intelligent robot. What we are doing is we are building robotic arms that have this intelligence very, centrally baked into it, right? MJ can explain a little more into what are the higher level intelligent layers. But what we are building, like physically, if you come down to our office, that is one floor of our office where we have multiple, uh, arms, robotic arms, fully designed, fabricated, and programmed and built in house. So we have a single arm with about 5 kg payload, with force feedback, 7 degrees of freedom, highly human like with tactile sensing. That's like one single arm. You put two of them together, that becomes like a dual arm bimanual configuration, or like a semi humanoid configuration. And then we have a mobile base onto which this dual arm can be put, and it basically becomes a fully semi humanoid robot. So we call them Uno, Duo, and Omni, right? Now, that's the hardware part of it. What really ties all this together is the physical intelligence part of it, called PR5, right? And MJ works on that piece, and MJ can take you through that. Yeah.
Yeah. So Basically, Hari, so what we give when a customer comes to us, obviously he comes with an application in mind. I have so and so application that I really want to automate. Can you do so, right? So what we give is an intelligent, complete solution, which is hardware and software, in-house developed hardware and software put together to actually sit at the shop floor and automate that application of his. Now, while Ravi has mentioned the hardware part, the ARM part, now what sits on top of the hardware and embedded layer is the software, where which we call as PR5, PHI, kind of a short form for physical intelligence, where we have it's a ROS2 based control layer at the bottom, where which accesses all the hardware, actuators, mobile platform, all the sensors in a ROS2 environment. And what PRFA actually does is it does two things. One is we have an in-house approach for called orchestrated AI, wherein we fuse different the pockets of AI intelligent models with existing state-of-the-art proven planning software, etc., and kind of orchestrate them together to give an application to the customer. That's one thing that it does. And in that process, what we have actually did is we have done a lot of abstraction so that we can give the solution to the customer as soon as possible. For example, we've divided uh, you know typical tasks that applications that a customer would do into something we call as skills. For example, visual servo, meaning go after an object wherever it is, however it is oriented. And if I have to explain visual servo in simple terms, that is a skill for the robot. Now, when I say skill, it involves intelligent software, perception, and actuation all put together into a modular, a submodule called visual servo. Similarly, do a slip-free grasp of an object is a skill. Do an insertion fit or a force-based assembly is a skill. So we have built such modular skills at the top layer so that, for example, if a customer comes to us and says, look, I have this alternator for a car I need to assemble, or maybe I have this phone that I wanted to assemble. We pick these individual skills, train them on customers' parts, stitch them together, and should be able to give an application really quickly. So that's broadly, the experience that we want to give to customers.
Uh, okay. Which sectors are immediately of most interest for you all at Perceptyne?
Yeah, I'll just so Hari, well, the technology, like you realized, it is very horizontal in nature with applicability across industries. Uh, Today, prima facie, we are focusing on the automotive tier one and tier two supplier ecosystem companies, as well as the electronics manufacturing services companies that help assemble phones and all the electronics goods. So these two are the primary verticals that we are focusing on. Having said that, it has wide applicability in the pharma space, in the food assembly space, and in general the warehousing and material movement space. But which would eventually would add on those verticals too. But today, as we speak, our focus primarily lies in electronics and automotive sectors.
And in terms of your sort of commercialization roadmap, where are you at today? And do you already have some pilot deployments?
Yeah, Hari. So we are deploying actually on the lines at some of our early customers, and we're also doing pilot deployments for a few. In fact, we're working with some of the world's largest names in automotive tier ones, as well as in electronics, consumer electronics manufacturing as we speak. Some of them for deployments and some of them for pilots.
In the current models that you are building, how do the robots get power? Do they get power from the assembly lines, or do they have battery packs and so on? What is the current technology that you have developed?
So that's basically a small configuration option, we can say, Hari. Both are possible.
So Ravi said three models, right? Omni, Duo and Omni. So the Duo are, usually meant to be stationary on the shop floor. These get powered from the assembly line. But the mobile version of it with a mobile base is battery powered.
They get to replace their own batteries too once that discharging.
Mrutyunjaya, you mentioned the sort of long term ambition is to build robots that are as general purpose as you can make them. And you've hinted at that, the current state of affairs in terms of being able to equip your products with different skills. So is that possible now, sort of on the go? And so can you give us a sense of where you are at in terms of how general purpose your products are currently?
Yeah, yeah, Happy. So, as I said, right, the problem that we're trying to solve here is, you know, uh, kind of relieve customers, manufacturing and assembly, plant leadership of the need to customize the hardware, the software, jigs and fixtures for every single application, right? So what we're building are general purpose, flexible, intelligent robots to that. And even today, and as we reach out to customers, the kind of applications, the kind of deployments, and the pilots that we're doing are actually quite varied. And because of the layered modular architecture that we have put together, for us, it's a matter of orchestrating things, for the specific application and giving it to customers today. So, in that sense, the generality that is already there with the robot today is way ahead of probably what a traditional automation can do. Now, where we want to get in the future is really to let's say a customer approaches us with his application, and it should really be a matter of few days or a week for us to actually build the top level application layer, orchestrate these things, and give it to the customers. This is generally that we are aiming at in the future.
Do you see this as a software approach, or a combination of software and hardware? What is your approach to this?
It's definitely a combination of both hardware and software, Hari. 100%. In fact, that is a very defining aspect of what we're building also. Um, in fact, it's a borderline of we can say a school of thought. There are, I think, some schools of thought which are a little extreme, and they think that this is entirely a software and intelligence problem. We don't think so at all. 100% this is a software plus hardware problem. Let me take a few sort of extreme sort of thought experiments for us to really realize this, right? See, mobile phone assembly is an extremely dexterous activity, or for that matter, any production line assembly task involves reasonable amount of dexterity and sensing, tactile sensing, and everything, right? If you imagine yourself just having vacuum grippers or maybe chopsticks, it's just be very, very difficult to do these things. It'll be extremely difficult to do a mobile phone assembly with just vacuum grippers, right? Suction based grippers. You need to have reasonable amount of dexterity like what is available to us humans, a for actually manipulating the objects in the desired orientations and forces, etc. But even before that, you need to actually sense the environments. In fact, there have been experiments done, physiology experiments, where the tactile sensing was suppressed by giving local anesthesia to subjects, and then they were asked to do simple tasks like just light a matchstick, right? People really struggle. Like, it's like really mind boggling, and to see people struggling with a basic task as to just picking up a matchstick, if the sensory modality called tactile sensing was suppressed, right? So what I mean to say is, if you don't have tactile sensing, if all that your software or even generally your AI depends on is only on visual feedback, it's very hard to operate in the physical world reliably. So you need visual feedback for sure. You need tactile feedback. You need force feedback at the sensory level. You need AI to actually capture all of these and use state of the art models and architectures to translate them into robust actions. And then you also need end effectors, or hands that can follow these commands and manipulate objects in real world with sufficient amount of dexterity. So it's 100% sensory improvements have to be done. AI, there are a lot more number of improvements to be done, and actuation also has to be really good. So it's definitely a problem of hardware and software.
So if you put it this way, then what does that curve or the journey look like, or roadmap look like, to all of you? Not necessarily just at Perceptyne, but even as an ecosystem and an industry, to go from what Mrutyunjaya you said, it should take you only a few days to make your robots ready for a new task, to a point where the robot should sort of learn on its own and just, it should, if you tell it that this is what I need you to do, almost like talking to a human worker, the robot should be able to understand what you're saying and do that task. I mean, is that a very long journey? Are we talking about decades, or do you think that will happen in the coming years? Where are we at?
Now, if you talk to any manufacturing leader, he or she would have loved to automate a lot of things for obvious reasons, for quality, reliability, throughput, and so on, right? Now the question comes as, why is it, despite a strong need for and willingness to automate from a leadership perspective, why is it that so many stations are not being automated? Right now, if you go into the details of this, you quickly realize that the problems are two pronged. One is the technical limitations of existing automation solutions to actually handle tasks that are done at assembly and manufacturing stations. I mean, I'll give you an example. If you probably stand before an automotive assembly line or an electronics assembly line, you will see people picking up parts from totes on, or maybe parts that are coming on a conveyor line, placing them before themselves, reaching out to different tools, reaching out to different cables, connectors, bearings, and small metal parts, plastic parts, etc. Pick them from so unorganized locations, and then actually nicely go on to another location, insert it, press fit it, arrange it, turn it, and do some similar operations and put it back in a tote or a conveyor line, and it goes to the next station. Right now, this sounds, from a manual operation standpoint, it's probably intuitive and easy. But if you think of automating this, right now, think of putting a traditional robot, which is a pick and place robot, which can pick from a particular fixed location and place it in a particular fixed location. You'll immediately run into problems like, okay, I mean, my input is very unorganized, right? My incoming parts are haphazard. A human can easily pick them up, but for a robot, you need to organize them very well, but they're not organized. Second, we're doing so many operations that involve touch feedback, force feedback. Actually, the snap fit, press fit is an operation where you use a combination of vision, touch, and force to very nicely do it. But robots today don't have those capabilities, right? Now, because of all of these things, what happens is you'll realize that, okay, I cannot automate these tasks as is they are. So let me figure out a way to, ease things up for robots. And you start building these custom jigs and fixtures. You build these precise, metal jigs fixtures, which will allow which will allow things to be arranged in a very, very deterministic fashion, and then robots can work on it. Now there is a problem there. The problem is that you first thing, building these custom things takes a lot of time, right? Time, iterations to perfect them, and so on. Now, in today's world, the number of products, the changes in products is happening much faster than it was a long time ago. For example, just to give you an example, if you take for example, Tata Nexon, right? There are more than 100 variants of Nexon in the market today. Compared to 15 years ago, a Tata Manza would have had probably 4 variants when it was launched. Now, this is because consumer preferences are changing. Everyone wants a bit of a personalization in what they buy and so on. For whatever reasons, manufacturers are ending up giving a lot more variants. The SKUs that are being manufactured on a line or assembled on a line are changing much faster. Now, come back to the automation problem. If you build customized jigs, fixtures, a whole lot of customized automation solution, and the product itself undergoes a change in 6 months from now, or maybe 1 year from now, you'll have to repeat the whole effort. There is no question of ROI, right? So, net, the summary is that what's happening here is a lot of stations are remaining unautomated because, one, either you cannot technically solve the problems of force feedback, touch feedback, and working with unorganized solutions, or two, you build a highly customized solution which is not general purpose enough to adapt to future and does not give you the ROI. And this is precisely the problem that we have set out to solve. Can we build solutions, automation solutions, that are intelligent, dexterous like humans are, and general purpose, and flexible, so that they can be adapted to different kinds of tasks and are affordable to customers?
Today, to get a robot to really do the automation that you want on an assembly station, at an assembly station, it takes anywhere like 3 or even 6 months of continuous mechanical engineering effort to really structure everything around the robot, to hard code all the corner cases and everything, right? So already 2 days, if you're able to train a robot, with these experience recordings that MJ was talking about and Jagga was talking about, 2 days is already like a, 2 orders of magnitude improvement. Like, that is something that is already really, really good. And what you are talking about, which is like, really just, give a language instruction and then go ahead, that will be really, the holy grail that I would say two things about it. Uh, it might take quite a bit time. Like, I would actually think of that it might take a decade or so. But more than that, we need systems that are reliable and operate in the shop floor today, right? We can't wait for reliability, especially in the field of physical automation, where each mistake is very, very expensive. So we cannot actually uh, afford to put systems that have only 90% accuracy or 95% accuracy. It is okay if ChatGPT hallucinates an answer for you, because you will anyway do like a secondary check if it's too important and critical for you. It's okay if it hallucinates, but robot that's picking up a 10,000 rupees mobile phone PCB assembly and then really does some damage to it, it's totally not okay, because these industries work on real strong reliability metrics that they want to achieve, that it's totally not okay for such a thing to happen. So I think mainly it's the reliability side where the cool demos have to catch up, right? I mean, we see a lot of these demos of robots doing impressive stuff, but to translate those YouTube videos into reliable shop floor deployments, I think that is where it takes time. Yeah. So that's why I think it is some good way before the end-to-end AI really shows the promise. And a very good pragmatic midway is exactly what our approach is. What Mrutyunjaya highlighted as an orchestrated AI approach, where we still use the state-of-the-art AI models, but then give a solution that is reliable, robust, explainable, revenue generating today, and not wait for the future models. Yeah, that's how I put it. Yeah.
One thing that I probably missed mentioning earlier, thanks for reminding through this question, is the integration of something called mutation learning based models onto the intelligence of the robot. Now, what we are doing as part of the PR5 layer, the physical intelligence layer, also is that, you know, a human operator would actually teach the robot by doing the task himself, or he'll make the robot do a task of assembly, or some sort of manufacturing line task, by making the robot do this task probably 20 times, 30 times, or 40 times. In this process, the whole suite of sensory perception suite that we have, which includes vision sensing, depth sensing, force sensing, and touch sensing on the robot, uh, acquires, that's something called experience recording. It actually tries to understand how are each of these sensory modalities being utilized, being applied, and being perceived by the intelligence through these demonstrations that are done by the operator. Now, once these experience recordings are in place, those recordings will be used to fine tune the AI models, the pre-trained AI models, on that specific task, and the robot should be able to do that task, autonomously by itself. And this is a work in progress. We are already have a layer of imitation learning, teleoperation for data collection, and using that data to fine tune our AI models. We are seeing some great results. I think the whole world is working towards this, this autonomy, where you see Google DeepMind, you see NVIDIA Groot and 1.5, you see a company called Physical Intelligence has their models called Pi 0, Pi 0.5, and there's some efforts but in other places as well. And there is a great progress that has been made in this front compared to where we were a couple of years ago. But are we at a place where this can be deployed in the industry right away? I think we're still getting there. And this is where our layer of orchestrated intelligence will help. So what we're doing with orchestrated intelligence, that layer that layer that in PR5 is we are taking AI models, islandic AI models, which are reliable, stitching them together so that we have explainability and reliability, and we can actually deploy this intelligence today and not wait for, having this intelligence matured to a Six Sigma, maybe which might take a few years, right? So I don't know if I'm able to answer the question, but this is a broader perspective. It's hard to put a timeline, but yeah.
To add to what Ravi and Mrutyunjaya said, Hari, so typically, to this problem, right? Some people treat it as a data shortage problem. All the LLMs and all have been trained on the wider internet scale data, but for the physical world, there is no such pool of data that companies can build on. So a lot of companies, try to supplement or augment this by actually doing the teleoperation setup, through the setup, trying to capture or record experiences while physically operating few objects in the real world, and also putting them in the simulation world and trying to generate some synthetic data around it. So a lot of, in general, one school of thought there is to kind of keep generating more of this data and eventually, put them into the traditional LLM kind of frameworks that are there, or fewer variations, what we call VLA models that are there, and try to see that data might solve the problem, and they expect that maybe a few years down the line we should have enough of these to be able to solve it. But like I said, our focus is more on trying to orchestrate uh, certain pieces of skill modules we've developed for a certain reliability, and actually get to applications much faster. At the industrial level, reliability becomes really important.
So if you want to extend the conversation on the sort of middle path, um, I think infusing humanoids into a conversation of robots, I think complicates things that much more. And maybe we have to wait and see if what the co-founder of the Boston Dynamics company recently said, this is not for YouTube Atlas famous last words, or whether they will be prophetic. We'll see. Time will tell. But my question to you is, what is your sort of view on this? Uh, do you think uh, humanoids are the way to go, or do you think, like several other robotics companies founders are also talking about, that you focus on what is actually needed in terms of the functionalities of these robots today? So therefore, it does not necessarily need to be a biped or something. The sort of lower half of the robot could be anything. It could be a tugger, or it could be something else. How are you looking at this?
I think, Hari, what we think are needed definitely are certain capabilities that make humans as generic as they are today, meaning the perception capabilities, the ability to perceive the environment, understand the context of the environment is something that really helps humans. I think that is certainly needed for humans. Second, the ability of humans to actually dexterously navigate and physically interact with objects is something that is certainly needed. I mean, that gives them the generality. And third, connecting these two, the rich perception and the great actuation, is the intelligence to learn and intelligence to adapt to environments, intelligence to actually course correct if something goes wrong dynamically. I think that's certainly needed. Now, we think that these three elements, when put in robots, make them intelligent, generic, and flexible. Now, whether we call it a humanoid or whether we give it a human form factor or not, I think is secondary. I mean, as long as these capabilities, are incorporated into robots, and they can be as flexible and as generic, that's really something that I think is important. And like you rightly said, right? Do we need to add biped, locomotion to humans? Probably for a household use case, there is more utility to biped locomotion, but in an industrial use case, the use case that we are talking about, maybe 99%, more than 99% of shop floors can be addressed with a wheel locomotion, and it's simpler, it's faster, and it's less nonsense and quickly deployable, right? So that we kind of take those practical approaches. Calling it a humanoid or not is probably secondary, as long as we solve the customer's pain point is how I would put it.
Okay. Uh, can we talk a little bit about the ecosystem in India that's germane to your work? You're building this company and your products largely out of Hyderabad. Um, can you give us a sense of what the robotics ecosystem looks like for you in India? I mean, from upstream in terms of even your pipeline for talent, all the way through your supply chains, component vendors, and of course potential customers. And I get that a company like yours, by the very nature of what you're doing, will probably see all markets as potential markets and not just India. But that said, just give us a sense of what all of this looks like for you.
So that Hari, just to put a fact out there, right? Uh, India, I think last year imported close to 9,000 robots. That's the consumption, and there's no credible domestic player manufacturing robots yet in India. So prima facie, the ecosystem around making robots is absent, and maybe there is a bit layer where using robots to solve for a solution, that mid system integration layer is what is decently there. And also the fact that the global metric that is tracked on the number of robots per 10,000 industrial workers, India is at a mere 7 on that number, and China is somewhere close to 400 to around 450. And the most bigger, the country with the highest number there is around with South Korea, with around close to 1,000 per 10,000 this thing. So again, citing these numbers, prima facie saying that the ecosystem per se on building robots and deployment compared to the developed nations or developing, at least compared to China, we're just barely there. So right from the supply chain at the bottom, when we chose to really build our robots here, we were and also owing to our technology architecture that we put it, we had to really design things completely grounds up and really put things together on right from our PCB boards to our sensors, our actuators, fully assembled actuators, and the robots all together, and uh, develop few vendors maybe for the kind of quality of precision parts that we require. Having said that, magnets is a dependency the world has on China, and today we import few frameless motors for that. But eventually, we plan to even localize that in India as we keep scaling our production. Uh, that's more on the supply chain front, Hari. But on the talent front, especially in the space, like Ravi and MJ put it right, we see the problem both as a combined hardware and software problem. It's not merely a software problem. Elements of hardware itself that we had to be solved before software can really make a big difference here. So while the hardware side, we are building our own robots. On the software front, primarily there is good, what you call, talent available on the intelligence side of things, where at least colleges like the IITs, the triple IITs, and the ISC and all, there are decent amount of supply of talent on that front, where we are able to leverage them to build our we've been fortunate to hire some really great talent from this prestigious institutions, and we are able to put together this software layer, augmenting them with all the hardware required for testing and other things. So that has been a good go for us. While also being in Hyderabad, Hyderabad has IIT Hyderabad, Triplet Hyderabad, and good schools around, from which we're really able to leverage and build these things. Hari. So yeah, that's primarily on how it's structured right now from India, and I think it's as we keep progressing and also as we see more capital pouring into this space, we only see this improving going forward. And also, now that since I think we've started in little mid 2022. Now I think there are lot more companies that are coming up in this space, and we see that this is going to be a very active space as we go forward.
Yeah, I think very good points, Jagga. So, just I think overall to add deep tech as a thing also, is really picking up traction now, Hari. I mean, in addition to everything that Jagga said, I think being in robotics, in cutting edge, deep tech fields now is more attractive than it was even 4 5 years ago. Especially government has announced the 1 lakh crore RDI initiative. I think that is going to be a real booster for us, because we have to invest in R&D as a nation, for us to work on and really develop and fine tune these cutting edge technologies. So I think talent wise, we are slowly getting there. Capital is coming in now, owing to the more interest from VCs as well as government in building deep tech. And yeah, I think it's only some more time before multiple companies like ours are in the robotics, deep tech robotics space, and I think it's going to be a good thing. That's what I fully believe. Yeah.
Just a point here, Hari, so this right. I think from a talent standpoint, India has amazing set of people. I mean, we really have some of the best talent in the world. And there are so many people who really want to do things on the ground. They want to, work on very interesting areas, interdisciplinary areas like robotics. And it is now the companies like ours are actually providing a platform and an opportunity for people to do things that they want to do. And we also see that a lot of people now we are seeing a little bit of a reverse brain drain. People who went to US, studied there, and actually preferring to come back. So, I mean, probably through your podcast, what I would say is, for people who really want to do things on the ground, work on physical things, a combination of software and hardware, doing something in the real world. Whether you are a top talent in India or studied in US and looking to come back, probably this is a place to watch out for, and maybe you can look out for openings in Perceptyne, and if things seem to be interesting, you can always reach out to us.
In terms of manufacturing at some scale, what would you say is something really good to achieve in the coming years? And can you, I know a lot, there are so many variables, but can you give us a rough sense of uh, what you would like to do? When do you think you can get to shipping maybe 100 robots a year or 1,000 robots a year?
So on that front, Hari, I mean, like MJ said, we've already having some really great brand names with which we are doing pilots slash an early deployment phase. We see in general there is great interest, and maybe in a year or so with little early this thing, we should be able to reach 100 plus deployments. But I think post that, we see the growth would be much higher from there on. So we ourselves are planning to ramp up our production facility slash the things up, like more from a 3 to 5 year perspective. We plan to at least have an annual uh, you know installation base or new installations to be in few thousands in the 3 to 5 year time frame, Hari.
And it's totally doable, Hari, given that, India is, our manufacturing is ramping up, and already like last year, like Jagga said, 9,000 robots, were imported. So that definitely means there is strong domestic demand for sure. And given the technologies that we are building in, we do, plan to expand overseas and make sure that, we get the right customers for what we're building. So having multi-thousand deployment in our 3 years from now per year is definitely what we aim to achieve. Yeah, and looks like a very good possibility that we want to be aligned with. Yeah.
Manufacturing your robots, do you think doing that in your own factories is very core to your work, or are there elements of it that you can give to contract manufacturers?
There would be a journey towards it. In the beginning, yes, it would be fundamentally that we would own the entire end-to-end pieces. But as we scale, as we try to put in more capacity into it, there is always taking inspiration from automotive industry. There are smaller pieces that you would give it out to contract manufacturers, and then control the core crux critical quality aspects of it in house, the way automotive companies do, and then own that this thing, so that at end of the day, customer is going to ask you and not your vendors on why certain things are good or bad, right? So it's important as a company, what we feel is to own that final quality assembly and everything, and then take it forward. But that is a journey as we speak. I mean, in the beginning, we would own everything end to end. As we keep scaling up, we would also build in our own supply partners slash contract manufacturers with whom we'll develop them into manufacturing certain pieces for us with our quality standards.
Okay. This year, what would you say are the top developments in your industry that you are really excited about, that you're looking forward to?
Sure. So I think 2026 is really going to be the year of deployment. Like, sort of, I know I'm echoing Boston Dynamics, leadership here. So, but I think that's indeed going to be the case. This is going to be the case of the year of deployments, where yeah, it's all good to see cool videos, but the real value of all the robots and physical intelligence lies in actual deployments that run 24 by 7 by any number of weeks, uninterrupted, robust, not needing it's the robots must not be a crutch. They should indeed be intelligent, and they should do things robustly and reliably. So I think that is going to be the key development, especially also given the strides in physical intelligence that are happening. So yeah, so the strides that happen in physical intelligence, especially from a prism of robustness, I think that's something that I'm super excited about and watchful for. Yeah.
I think over the last few years, physical intelligence has made a lot of noise, it's created a lot of attention. I think, and that's the first phase of any new exciting technology. I think this year is a year where that will be in some sense put to test on the rubber hits the road. People trying to make the rubber hit the road, and they'll see those initial learnings. A lot of learnings come their way, and it iterates to get better. I think that those learnings is what I know really looking forward to see, and we'll see the evolution of physical AI probably get better over time. Really looking forward to that.
Same 2026 question, but from a Perceptyne point of view, for you guys this year, what would you say are the top priorities?
I mean, just the standard things, Hari. Like, we want to build robust, no-nonsense technology, build strong, robust, explainable AI layers to reduce our deployment time. Most importantly, basically kick off the deployment curve. That's it. For us, these are the three simple goals.
I would probably add a bit of chronology to it. So I think, Hari, so 2022, I'd say was the journey. There's a story of inception of Perceptyne, how we all came together and identified a customer problem. In 22 to until recently was how we built Perceptyne and the products we built. It was a story of a great team and a set of great investors coming together and pulling off this complex product. Today, I think is a brewing story of initial customer successes in the writing today, right? In very near future, we want to see a lot more stories of innumerable customer successes as we progress. And eventually, we want this to be a story of deep tech success in India.
That's it for today. You can find the links to Perceptyne's website and its founders' bios in the show notes. I'll be back with another conversation soon. If you'd like to support my work, please subscribe to my posts at indiatechreport.in. I'm Hari Arakli. Thank you for listening.